Hello everybody, this is Kasher. Welcome to Crossy Road game with Python and Turtle. So I got a lot of requests in Facebook, like if I can make the tutorial or if I can share the code. Normally I don't share the code, I make tutorial for the codes. So promise is promise. I try to write the same game, and hopefully you will get the code by following my tutorial. Anyway, alright. So the idea of this Crossy Road is there is an object, or there is a guy, or whatever you wanna imagine it. So there's an object that's going to pass the street, cross the street, and there are some cars and coming and going, and at the end there's like maybe subway or not subway, maybe a bus or something, and pick the guy, and he can like survive or something like that. Anyway, so let's go to our tutorials. First thing first, we are going to need some modules. We are going to need the turtle, random, time, maybe, because maybe not, and math, and also mixer from Pygame because of the sound system. And actually I tried a couple of other mixers before, but I didn't like them, so I'm going to stick with Pygame mixer. So import turtle and random and math and time for now. And we don't need the Pygame mixer now, or we need it. We don't need it right now, but let's just import from Pygame, import the mixer, and we need to initiate the mixer. So this is mixer that we need, and let's create two simple constants. I am going to write here constants, and here we have width, and it will be 800, and height it's gonna be 600. Okay, now I'm going to create my screen. So screen setup will be screen equal turtle.screen with capital S, which give us the screen method, and screen.setup. Here we have width and height. So some programs used to do the same, do this screen method also within any class that they are making or writing, any class that they are writing for the game or whatever program. But actually I don't like that idea, so I like to keep things a little bit more simple than usual. And screen dot bg color, which give us the access for background color, I put it to green. And you can Google the available colors for turtle. You can also use a string as a predefined colors, or you can use RGB bit numbers. And also right away, screen dot tracer gonna be 0. Or you can also call it false, no difference. And it means we have the fastest refresh rate on the screen. And what else we need? And for now, let's create our main loop. So turtle, to keep this screen up and running, turtle.main loop. This is one way. You can also do screen.main loop until you have your own while loop, whatever that keep the program up and running. So I'm gonna keep this turtle.main loop and save it, and when we run the script we should have the green screen here, and maybe we can have here at the top the screen title here, say Crossy road, and again down here Crossy road. As you see here we have. Okay. Then the next thing, I'm going to create some random colors. Then I'm going to make a list with colors. Here I will have white, orange, and I will have a yellow. What else? Blue, and I'm gonna have gray. Actually, here this way. So okay, and all right. Now, the first thing I like to do is to create my player class. And every time, most of the time I'm working with Turtle, I'm using simple class methods and simple class structures. Now let's go to the class, we call it class player, and it will inherit everything from Turtle class, Turtle modules, and Turtle. Alright, and here define our constructor, and for now just have self, but later on will be more. And here we need to call the superclass super.init. Okay, what we need to do, just self.pen up, dispatch the pen from the canvas, self.pen up, and our shape is square, self.shape for now until later on we add some pixel art there. And here will be the shape will be square, and what about shape size? The self.shape size will be what? Will be 2, 2, 2, and 2, and self.set position will be on 0, the bottom of the screen, -250. And if you don't know, Turtle, unlike the Pygame, uses Cartesian coordinate system, which is the 0 is in the center of the canvas, and right and up is positive, and left and down is negative. So it's a little bit harder to calculate this way. And what about the color? Let's set that pen color equal blue, and then I'm going to create an object from this class, then player equal player for now. And because we have screen tracer here, we have to also use update method. Then I'm going to remove that Turtle main loop and create my own loop. So running equal true, and while running, then first thing to do is screen.update. Okay, and now run the game, and I have my object here. The object is a little bit big. I changed this to 1 and 1, which is exactly 10 pixel. Alright, what is the next thing we need to do? Let's think about the movement system. We can use the stepping system or jumping system or tile system, whatever you want to call it. Like every time you you move the object is almost like a jumping, like a frog or whatever. It's not smooth. Like, for example, like Pac-Man movement is very constant movement, very smooth, but or snake movement is very smooth. But this game, we are almost jumping. So here I'm going to say self dot in game speed equal 0 for now, and also self dot speed method will be 0. Speed method is different than this self because of this. I call this attribute in game speed, because we have another speed which is internal turtle method, and this is actually at the speed of your drawing. So, and now let's get to key binding. We have two systems for key binding, on key and on key press for turtle. And on key actually is when you remove your pressure, remove the pressure off the key, it's going to work. But we need to use on key press. That's another method with on key is a little bit different. It's we can use it for different stuff, but never mind for now. And for that, let's come down here. We create our event handling system for turtle, and turtle dot listen is going to listen to, I think, a screen, and it's like pygame.get method which you are using for listening to or waiting for event in Pygame. And here I'm going to need to have 4 movement, right, left, and up and down. So we need to have 4 different function for it, or we will see how I'm going to design it. It's kind, yeah, maybe. Alright, so let's come down here, say screen dot on key press, and I copy this line here, and let's say we have right method, right method, left, and up and down methods, so we know what we are going to write. Then player dot right, and every time we hit the we connect it to a right arrow key, okay. And also player dot left, which is the name of the method in our player class, and every time we hit the left button, it's going to call that method. And another one is player dot up, we connect it to up arrow key, and screen dot why I'm writing, I have it here, and screen dot key press, and going to be player dot down, and we bind it with down arrow key. Okay, this is our simple event handling or key binding and key binding here. Then I'm going to go up to my player class, and we define some methods here. To define right, self, and what we are going to here, let me just write these methods first. Pass, define left, self, pass, define up, self, pass and define down self and pass. Alright, let's say every time we click on up or down, we need to move our object. So what I'm going to do, I'm going to use goTo method from Turtle to move my object around. And for right, it's pretty simple actually. It's just self goTo self.xcore plus self in-game speed and self.ycore. So xcore and ycore is x coordinate and y coordinate of the object, and what I'm doing here is, let me show you. When we call these methods, for right, every time I push the right, it's going to move 7 pixels to the right because it's changing the position of the object. Here I am changing the position of x coordinate, and I'm adding 7 pixels to it by making like plus self in-game speed, and this y coordinate will be the same. Alright, so we do the same thing for left, self.goTo self.xcore minus self.in-game speed, and going to be self.ycore. And for up, self.goTo self.xcore without any change, because we are going to move our object vertically, and self.ycore plus self.in-game speed. Okay, and here self. For down, goTo self.xcore and self.ycore minus self.in-game speed. So let's see if our moving system is working as we want. Okay, left, right, up and down, and you can't go diagonal. Alright, and that is actually good. Okay, this is our moving system. And what we need for our so for our player class, we need one collision detection system and one update. So at least we can create the empty methods for now. Define, what we call it is collision, and here will be self and other, and pass for now, and define update method self and pass for now, because we are going to, especially the update method, we are going to develop it slowly depending on how our game's going. So but for collision, I think the best way for this sort of games, because unfortunately Turtle doesn't have any collision detection system like Pygame or rect collision, group collision, so we need to do it manually. And I've been trying to write some sort of rect collision for Turtle. I haven't had the time to complete it yet, but for now we need to use Pythagorean theorem, A equals self.xcore, and I'm not going to actually explain what is Pythagorean theorem. Please Google it. And this part, I think I explained it in my other Turtle videos. So other.xcore and here b equals self dot y core minus other dot y core, and we calculate the distance. Distance equal math dot square, and here a power 2 and plus, where is my plus, plus b power 2. Alright, so let's say let's set our distance and the base of our collision system. So if distance smaller than 25 pixel, then return true, and else return false, and that's it. That is our collision detection system. Pretty simple stuff for now. Okay, let's one more time, and alright, looks very okay for now. Okay, alright, I think it's enough for this video. We continue with our car class or mob class in next video, and that's all. Thanks for watching, and I see you in next video.